agreement that we did.
I would like to write this. Yes? No. Is this okay? I already jumped up and down. It cannot be correct. I cannot break the radical if it's a sum. Only product or ratio. So this will be horrible. Good. So then, yes? I cannot put it outside, if that's what you meant. That's why I needed those three formulas from day one. You see, they pop up all the time. Excellent. Excellent. How do I know that? First term squared plus 2 times the first times the second plus the second term squared. If you bear with me and you trust me and you remember, try to remember those three formulas, it will be a breeze. Factoring, I mean. So then what is the final answer then?
Absolute value of x.
Very good. Excellent. Good. Let's look on page 648. And let's choose anything from 15 through 19. And then I would like to review complex numbers. Okay, let's start with 17. In 17, we are told to square the square root of x plus 1. And then I would like to work on 18. Square root of 2 minus 4 multiplied by the square root of 3 plus 1. Okay. And then we'll look at another radical equation and complex numbers. How many terms will you give for the first one? And please do not say 2. Can anyone dictate? Ready? What is it?
X plus 2 the square root of x plus 1.
Perfect. What do I do with 18? I have no product, no special product. There is nothing I can do here. I have to FOIL. How much is the square root of 2 times the square root of 3? 6. Good. Plus the square root of 2 times 1. Square root of 2. Negative 4 times the square root of 3. Just that. Negative 4 is the square root of 3. And negative 4 times 1 is negative 4. Are these like radicals? No. Okay, let's look at another radical equation. Let's say 22. X equals the square root of x minus 2 plus 2. And then I would like to find a radical equation with 2 radicals. I found one on page 646. Okay, first step, please. Absolutely. What do I write?
Or x minus 2 equals.
Excellent. Perfect. What should I do next? Very good, excellent. Not term by term. I didn't say you said that. I'm just reminding you, not term by term. The left-hand side is 1 unit. The right-hand side is 1 unit. What do I get on the left? And please do not say 2 terms.
X squared minus 4x plus 4.
See, once you see it, you will never forget it, right? Once you understand it, once you practice it, it will click and it will stay.
So, where
Yes.
does the plus 4 come from?
From the contract. First term squared minus 2 times the first times the second plus the second term squared. Right? The right-hand side. I forgot to ask, what type of equation is this? Right. And the right-hand side? What type of equation is this now? Right. How do I solve a quadratic? Yes. Set it equal to 0. So then I have x squared. I have to subtract x. And I have to add 2. Did we just do this problem? No, I think it was something else. It's very similar, isn't it? Yeah, very similar. Okay. Good. And now you know the factored form, right? No, it's not the same factored form. Sorry. So the product must be what? 6. So and the sum must be good. Since the product is a positive number, both numbers I'm looking for must be the same, have the same sign. But since their sum is negative, now I know which sign they have to have. Which sign do they have to have? If their sum is negative, they have to have the same sign. Negative, of course. So can we find two numbers whose product is 6? Two negative numbers whose product is 6 and whose sum is negative 5. Yes, negative 2 and negative 3. So x minus 2 and x minus 3. So what are the options? We're applying the zero product principle. What will be the answers here? Exactly. But remember, they come with a huge question mark. Why? Because we use the power, the principle of powers, and we know that that principle is tricky. It cannot always be trusted. Therefore, we have to go back and check. Back and check exactly in the original problem. Nowhere else on the road. Nowhere else. Just the original problem. So I'm going to copy the original problem here. And I will plug in 2. 2 minus 2 is 0. The square root of 0 is 0. 0 plus 2, is that 2? I will say yes. Next to x equals 2. Now I'm going to check 3. 3 minus 2 is 1. Square root of 1 is 1. 1 plus 2 is 3. I'm going to write yes. And both work. So this equation happens to have 2 solutions. I want to look at a radical equation with 2 radicals and then complex numbers. So the square root of x plus 9 equals 2 plus the square root of x minus 7. And this is problem 122 on 646. This situation is more complicated. It has 2 radicals. So squaring both sides once, it will not do the job. Down the road, you will see what happens. I will have to square the second time. Okay, so what type of equation is it? Radical. How do I solve a radical equation with square roots in it? Because if it had cube roots in it, I would have done something else. If it had fourth roots in it, I would have done something else as well. But it has square roots. So what do I have to do to both sides? Not term by term, but as a whole unit. Square. Good. When I square the left-hand side, that's not a problem. What do I get? Perfect. But when I square the right-hand side, that's not easy. I remember my contract. I know I will have to write 3 quantities, 3 entities, and then see what happens. The first part is what? 4 plus 2 times the first times the second. Plus, perfect, the second term squared. This is my second term, and I have to square it. Excellent. Don't do anything just for a moment. Let's look at it and talk about it. I see everything is nice and friendly, but I still have a radical in it. So now I have to keep this on this side. Everything else moves to the other. This moves here, this moves here, this moves here. Like before, I have to isolate the radical remaining in the problem. So the right-hand side will have 4 the square root of x minus 7. And the left-hand side, well, luckily, I can subtract x. When I subtract x from both sides, x goes away. So I have a 4, and I have a negative 7. Well, this is negative 3. So I'm adding 3 to both sides. It was negative 3. I move it to the other side. It's positive 3. And I have a 9. I have a 9 on that side, and I'm bringing a 3 over. What do I have on the left-hand side then? 12. Positive, right? Remember the two key words. Whenever you think of math, 2 key words should be on your mind. What? Factor and simplify. These are the 2 key words. They have to stay in your brain forever. I would like to simplify this. Is there a way of simplifying it? Dividing both sides by? Exactly. Do I have to? No. It's easier when I square. So 12 divided by 4 is, and the right-hand side is the square root of x minus 7. This is much easier to square. Now I have to square again. I square the left, I square the right. The left-hand side is, the right-hand side is, and finally x. What type of equation is this, by the way? Initially, I started with an equation with 2 radicals. I squared both sides. I got into an equation with 1 radical. I squared again. I had to. And now what type of equation is this? Linear. So I'm just moving 7 to the other side. So x equals. But again, it comes with a huge question mark. No one guarantees that this works. No one. Because this is a principle that doesn't guarantee anything. You have to go back and check. So I go back to the original problem. I'm going to copy the original problem. This is not the original problem. This is not part of the original problem. So this is the original problem. So I replace x by 16 everywhere. See if I get the true statement. 16 plus 9 is 25, the square root of 5. 2, 16 minus 7 is 9, the square root of 9 is 3. Is this acceptable? If you accept this, then you have to accept this. Is this okay? Yes? Okay. I'd like to go back to page 648, and I want to look at problems with complex numbers. I like to look at a graph, and then I like to go back to chapter 9. So quickly, because I only have 20 minutes left. Gee, 25. Yes, 25, right? I know. Okay, let's look at 29. We have 4 plus 3i everything squared. We're asked to simplify this. And then I would like to look at 30. 1 plus 4i divided by 1 minus I. And then I would like to look at just I to 2017. Okay, I have sort of a binomial squared. How many terms will I get when I square a binomial? And please do not say 2. 3. So the first term squared plus 2 times 3 is 6. 6 times 4 is 24i. Plus the second term squared. Right, but I have to write 9i squared. So 3i times 3i. So 9i squared. What do I know about I squared? -1. 9 times -1 is -9. 16 minus 9. You have $16, you give me 9, so it's 7 plus 24i. This is it. How do we divide two complex numbers? It's like rationalizing the denominator, the same kind of process. I have to do what? Yes? Multiply by? It has to be the conjugate. 1 plus I, 1 plus I. Okay. Let's use this special product we reviewed on our contract for the denominator. And the numerator has to be distributed. So 1 minus I times 1 plus I is first term squared. How much? Minus the second term squared. How much? I squared. Good. We'll come back and replace I squared in a minute. Now the top I have to distribute. 1 times 1. 1. 1 times I. 4i times 1. And plus 4i times I. 4. Very good. Now I can go back top and bottom and say, but I squared must be replaced by -1. So now the denominator. 1 minus -1. How much? Very good. The numerator. 1 minus 4. 1 minus 4 is -3. I plus 4i. 5i. We have to separate it. We have to write -3 over 2 plus 5 over 2i. We have to write a plus bi in other words. Let's raise the power of I. Let's find the power of I. I picked I to 2017. How do I simplify this? Remember, I only know I squared. But 2017 is not divisible by 2. So I will break it up into the first number that is divisible by 2. And it does not exceed 2017. So it's I raised to 2016 multiplied by I to which power? 1. But this is an even power. So I can write I squared, and I'm waiting for you to tell me what to write up here, times I. Which operation I'm looking for to get that number in the box? I I with the 2 with this number should give me that. What operation? Add, subtract, or multiply, or divide? Which one? I didn't hear. I talked at the same time with you. I'm sorry. Of course. So 2 times what is 2016? 1008. Good. What do I replace I squared by? Good. So -1 to 1008 multiplied by I. But -1 raised to an even power will always give us +1. And +1 times I is so remember, I to any power you want can give you 4 possible results. I, -I, 1, or -1. You cannot obtain any other result. And you should practice. You should just say, okay, I to the 17th, I to the 555, I to the 50th, and I to the 35. And see, you cannot get anything else but one of these 4.
If I always equals -1, that would be
Not I. I squared equals -1.
Okay.
Just remember, right? I squared is -1, but I is the square root of -1. So we don't want to mess with that. It's okay just writing I or -I. But the only thing we can use is this. Nothing else. Okay. What about those graphs of the square root? Are you going to be okay with that? No. Okay. So let's choose a square root. But you will be okay because you're going to review everything we've done. Okay. It's in your own benefit to raise your grade and feel comfortable with this. So please, for me, let's say this. We're asked to graph this function. When I'm asked to graph a function, what is my first thought? Always, forever, the first thought. Finding the... Exactly. Exactly. That's my first thought. Good. So I'm looking at this function. What type of function is it? Yes, it's a square root. Are there any restrictions on the square root, or the domain all real numbers? It's not a friendly function. Okay. So what has to happen for the square root to exist? In other words, I'm asking, what type of number should x plus 3 be so I can take the square root from it? Or 0. Yes. So what do I have to write? What has to be positive or 0? What should I write on this side? Not x. I don't have x under the radical. I have, what do I have under the radical? Exactly. I have x plus 3. X plus 3 must be greater than or equal to 0, not x alone. Okay. So I move 3. So I get this. So can anyone identify the domain for us? Careful. Greater than or equal to -3. Greater than or equal to -3. So where do I start? Thank you. So then I have x, I have f of x, and I have to have -3 to infinity. I have to show all this work. Yes, I know you can graph it with the graphing calculator, but you have to show me this work, please. Okay, so I need to pick 2 more x values, get 3 points, and graph the function. I have to start by plugging in -3, but I need 2 more numbers. Give me 2 more numbers that is easy to, only after you add. Yes, 1 is perfect. And 1 more. 3 plus 3 will be the square root of 6. It's not wrong. It's not a mistake, but I can take the square root from 6. 0, I cannot take the square root from 3. 6 indeed. Good. So please plug in -3. What do you get? It's negative 3 plus 3, which is, the square root of 0 is? Excellent. Please plug in 1. Very good. Please plug in 6. Very good. That's all we need. So it starts at negative 3. That's what the domain is. At 1, we have 2. 3, 4, 5, 6. So we have 3. And we know the graph. We've graphed this function many times before. Square root of x plus 3. I will ask you to identify the range. What is the range of this function? The range is? Indeed, as we expected. It's a pure, just one little transformation in there. Okay, so what if I have this? Let's say I have 3, x, and 5. I'm asked to find x. What do I have to write? Excellent. The sum of the legs squared equals the longest side squared, the hypotenuse squared. Okay, very good. So this is x squared equals 5 squared minus 3 squared. So x equals, or let's write x squared first. How much is 5 squared? Minus 9. So then x squared equals 16. I will take the square root, that's the taking square root principle. And then I get x equals, you're right, the absolute value of x, I agree, equals what? How much is the square root of 16? 4. So there are two options. We're going to review chapter 9 right now. What are the options for this equation? I'm looking for numbers x whose distance from 0 is 4. Which numbers are there? 4 and negative 4 indeed. X equals 4, x equals negative 4. However, this has no place in this particular problem. Why? Because it's a distance. So this is the only one. Let's go back to chapter 9. Chapter 9, review, chapter test, on page. I want to also show you, please find the time. I will miss this book because I told you the last time we teach this is next summer. I will miss this book. Here's why. Because it has, maybe the book we're going to adopt, whatever, has this too. But for example, it has these highlights for all chapters. At the end of each chapter, we have highlights. It says here, definitions and concepts. It says here, examples. 9.1, 9.2, 9.2 here, 9.3, 9.4. So I would definitely check myself with all these, because these are the concepts that the chapter is presenting. So I would definitely do that. So let's look at, and these highlights are at the end of each chapter. Okay, on page 583. Let's review the 3 sections from chapter 9. For example, problem 3 on page 583. The absolute value of x minus 5 equals the absolute value of x plus 2. And then I'm going to write also 6. You don't have to copy more than one. I'll allow you time to copy. Okay, so what type of equation is this? You cannot say radical. You cannot say linear. You cannot say quadratic. You cannot say rational. Or what is it? Right. It has absolute value in it. It has to be absolute value. Perfect. So we know that absolute value equations can result into 4 different options. 1 solution, 2 solutions, no solutions, infinite. So please keep that in mind. 4. Good. So I don't know what to expect here. Have no idea. But I know that I'll have to have option 1 and I have to have option 2. What does option 1 say? Perfect. And option 2 says? Exactly like here. So they're either both positive when one is positive and one is negative. I see the cell phone under the table. Good. So how do I solve the first one? I subtract x from both sides and I get the -5 equals 2. What will you say about this? False. Not possible. Good. The next one is x minus 5 equals -x minus 2. We agree that we need to distribute -1? Good. So I move -x to the other side. It becomes positive, so I have 2x. I move 5 to the other side. It's negative here. It's going to be positive on the other side. So 5 minus 2 is 3. So the only solution is 3/2. So it happens that this equation has only one solution. Now let's look at this inequality. When we look at what type of inequality is this? Is it radical? Is it rational? Is it linear? Is it quadratic? No, it's absolute value. There are only 2 options for absolute value inequalities. So maybe this will trigger your memory, right? Remember, one option is this. The other option is this. Just 2, right? This or this. Closer to 0 or further away from 0. So let's read this. But first it's not cleaned up, so we have to clean it up first. How do I clean this up? Exactly. The absolute value of x minus 5 less than 2. And now I read x minus 5 less than 2. Less than 2. So how do I translate this? Oh, I'm sorry.
Less than x.
Okay, let's do this again. We are trying to find numbers whose distance from 0 is less than 2 units. Where will I find these numbers? Less than 2 units. Between what? Between -2 and? That's what I have to write. Between -2 and 2. This is what I have to write. If it's in between, I have to write between -2 and 2. How do I solve this? Good. So 3 less than x less than 7. And this is the solution. How do I write it in interval notation? Yes. That's it. So please be careful because this may be confusing. Don't try to memorize. There is no point. Just think. Okay. Here is the next problem. Let's say 12, in which I have 17x minus 1/5 greater than -2. Remember, you cannot treat the absolute value by adding, subtracting, multiplying inside, nothing. Nothing. You can't touch that. So what type of number is this? Always. What type of number is this? So I'm telling you that a positive number is greater than a negative number. Does that depend on anything? So how many solutions does this inequality have? All of them. No matter what you do, a positive number will always be greater than a negative number. Okay, let's look at one more. Like, for example, 5. Have the absolute value of 3x plus 1 greater than 5. Now, let's think for a minute. I cover this. I'm asked to find these numbers, whatever they are, whose distance from 0 is more than 5 units. Distance from 0 is more than 5 units. I cannot write it as a chain. It's this. They have nothing in common. It's not this as a chain. It's this. So what are the options here? 2 completely separated options. Excellent. So please remember this. Easier to understand than memorize. So I'm going to subtract 1, so 3x greater than 4, x greater than 4/3. I'm done with the first one. I'm going to subtract 1 like I did before, 3x less than -6, divide by 3. I'm done with the second one. Remember, this one will always have to have the union in between. So, what will you say? Yes, I have to start with this one, negative infinity, -2, union, 4/3, infinity. X is in this interval. The X can be chosen in this interval. Okay, 6 more minutes. Let's look at 17. We have 2y minus x greater than or equal to 1 and x plus y greater than or equal to -4. Question now. Graph the solutions of the following system of linear inequalities. How do I start? What do I do? What is the idea here? So I have to write the equation first. Although I'm not changing the inequality into an equation. I need the equation. So I have to write 2y minus x equals 1. I think I can remove this now. Good. I have to find 2 points. When x is 0, I cover it. How much is y? Very good. And the ordered pair is? Comma 1/2. And now when y is 0, I cover it. How much is x? -1. So -1 comma 0. So we are ready to graph now this line. This is not the inequality. This is just a line. So 0, 1/2. Oops, that's not good. 0, 1/2 is here. And -1, 0 is here. Now I have to stop for a moment and go back to the inequality and see if it has the equal symbol. Does it have the equal symbol? which means that the line will be solid or not. Solid. I write on the equation, on the line, I write 2y minus x equals 1. Notice that I did not write the inequality. I wrote the equation. I see that this line divides the entire plane into two regions. So I will be using the origin, and then I remember that I will check the lower part. So come back to the inequality. 0, 0. Is 0 greater than or equal to 1? True or false? False. So I cannot choose or shade in the area where I have the origin, where the origin is, but I have to shade in the opposite. So this is 2y minus x greater than or equal to 1. Because if the origin didn't do the trick, no other point will. I repeat the steps with the other inequality. X plus y equals negative 4. When x is 0, y is negative, right? So 0, negative 4. When y is 0, I cover it. X is negative 4. So negative 4, comma 0. Correct? Good. So now negative 4, negative 4. This is negative 1, 2, 3, 4. And 0, negative 4, 1, 2, 3, 4. Do I graph it as a solid line? Good. This is just a line. X plus y equals negative 4. It does not pass through the origin. If the line passes through the origin, I cannot use the origin. So it does not pass through the origin. So I go back to the inequality. I use 0, 0. By using 0, 0, I'm checking the upper territory. So here's my 0, 0. 0 greater than or equal to negative 4. True or false? True. So I have to shade in the region that has the point that I checked with. So this is x plus y greater than or equal to negative 4. And this, everything in orange is the territory representing solutions to this. Everything in green is the territory representing solutions to the other one. Now what do I do with the green and orange? What do I do with green and orange? I intersect them because I want to find, that's what I was looking at, I want to find the common territory. This is both at the same time. And this is what I'm looking for because I want to solve the system. I want both conditions to be fulfilled at the same time. Any questions?